Hi everyone. I thought today we could practice a few secant, cosecant, tangent, and cotangent graphs, and then we could spend some time going backwards. So let's start. The first problem I want to do is y equals 2/3 secant pi x minus pi over 3 plus 7/3. So, the key to graphing secant is start by graphing cosine version first. I'm going to graph this as though it said cosine. Y equals 2/3 cosine pi x minus pi over 3 plus 7/3. And then when I'm done graphing cosine, I'll do the last two steps that will turn it into a secant graph. So we'll start by setting our argument, the stuff in parentheses, equal to 0 and equal to 2 pi. And we'll get x equals 1/3. And here, 6/3 plus 1/3 pi is 7/3, so pi x equals 7 pi over 3. But when we divide by pi, we get x equals 7/3. So here are my starting and ending points. 1/3, 7/3, halfway in between is 4/3, halfway in between is 5/6, and halfway in between is 11/6. Okay, so now I have my quarter points, good. And we know that this midline is y equals 7/3. We're going to go, because this is cosine, we're going to start high, go low, and back up again. Now, generally at this point is when I don't draw in the line like I would for cosine, but instead wherever cosine is equal to 0, secant has a vertical asymptote. And then I have to bend to those asymptotes. If it helps to draw in that secant, that cosine, to know that what you're reflecting against, you should do that. But make sure it's not the same color or it's not the same thickness as you use for the secant graph line. To graph these low and high points, I'll use my d value and my amplitude of 2/3. So 7/3 plus 2/3 is 9/3 or 3. 1/3, 3. 7/3, 3. And here we have 7/3 minus 2/3, which would be 5/3. So the x value here is 4/3. The y value here is 5/3. 5/3. Okie doke. That's our method. I guess I need to write in over here when cosine equals 0, draw vertical asymptotes, and C, sketch in secant x. Okay. Well, let's take a look at the second one I want to do, which is a cosecant problem. Cosecant. Y equals -4 cosecant x over 2 plus pi over 4 plus 10. Okay, we'll start again by graphing the sine version of this and by setting this argument equal to 0 and 2 pi. X over 2 plus pi over 4 equals 0. And x over 2 plus pi over 4 equals 2 pi. All right, we get x over 2 equals negative pi over 4. And when we multiply both sides by 2, we get x equals negative pi over 2. Here we get x over 2 equals 8 pi over 4 minus 1 pi over 4 is 7 pi over 4. And when we multiply both sides by 2, we get x equals 7 pi over 2. So negative pi over 2, 7 pi over 2, halfway is 3 pi over 2, halfway is 1 pi over 2, and halfway here is 5 pi over 2. Okay, this is y equals 10 here. And remember, we have this negative out in front. So yes, I'm going to start on the midline for sine, but I have to go down to the low, back to the midline, up to the high, back to the midline. So any place sine equals 0, draw a vertical asymptote. That means here and here and here. And just like we did with secant, with cosecant, now I need to sketch in, I don't need this sine graph. This sine graph is only to help me find the vertical asymptotes and the location of the high and low points. But my graph is the reciprocal of this, and therefore it's this blue graph. Please try and go all the way to the asymptotes. Now we just need to label that high point and that low point. We know that this line is y equals 10 and that our amplitude is 4. So we're going to go up 4 from 10 to get 5 pi over 2, 14. And we're going to go down 4 from 10 to get pi over 2, 6. There's our graph of secant. Notice we see these half periods, these complete half periods with cosecant. When I sketch sine, I'll always have 3 vertical asymptotes for cosecant. And as a result, cosecant is always going to come with half a period and half a period graphed. But when I graph secant, because that's coming from cosine, and cosine has only 2 zeros, it gets only 2 vertical asymptotes. And so I only end up with 1 half period, and then this quarter period here, and this quarter period here. So why does this matter? Well, it matters for the going backwards part. When I see this, I know we're talking about a secant graph. And when I see this, I know we're talking about a cosecant graph. So if I see 2 complete half periods, I'm going to be drawing this as a cosecant graph. And if I see a half period and 2 quarter periods, I'm going to be doing this as a secant graph. Okay, more on that in a few minutes. Let's take care of graphing tangent and cotangent. Okay, so our tangent graph, y equals tangent pi over 2x minus pi over 6 plus 5. Remember, amplitude doesn't play a role for us because we're not graphing with quarter points. And what do I set this equal to? It's not 0 and 2 pi and 4 pi. It's 0, pi, and 2 pi. Equal to 0, pi, 2 pi for 2 periods, This is for one period. This is because the period of tangent is only pi. Okay, so pi over 2x minus pi over 6 equals 0. Pi over 2x equals pi over 6. And when I multiply by the reciprocal, 2 over pi, I get that x equals 1/3. Now we need to set pi over 2x minus pi over 6 equal to pi, not 2 pi, pi. So pi over 2x equals 6 pi over 6 plus 1 pi over 6 is 7 pi over 6. And then multiply by the reciprocal, 2 over pi. The pi's cancel, the 2's cancel, and I get x equals 7/3. So these are where the vertical asymptotes are on the tangent graph. At 1/3 and at 7/3, I have vertical asymptotes. It's a tangent graph. It's a positive tangent graph, so I know its shape looks like this. This is y equals 5, and my c value is halfway between these 2 points. So what's halfway between 1/3 and 7/3? Well, that would be 4/3. 4/3 is, is my inflection point, and the y value there is 5. And that's my tangent graph. Okay, let's do a cotangent. In fact, let's do a negative cotangent. Wait a second. That problem was completely wrong. Wow. Oh, I'm sorry. Let's go back and do it properly. What was wrong about it? Who caught that? Because I certainly did. Oh my goodness. This is the problem we started with. And we did pi x over 2 minus pi over 6 equal to negative pi over 2. The vertical asymptotes for tangent are not at 0 and pi. That's where tangent is equal to 0. Oh my goodness. So let's be clear. Sine, cosine, secant, cosecant. I set the parentheses equal to 0, 2 pi, and if I'm doing that second period, 4 pi. For tangent, I set the argument equal to negative pi over 2 and positive pi over 2. Cotangent is what I set the argument equal to 0 and pi. And if I'm doing a second period, 2 pi. And here, if I'm doing a second period, 3 pi over 2. But remember, these are just for second period. These are what I primarily set my argument equal to. So I needed to be setting the argument equal to negative pi over 2 and positive pi over 2 before, not 0 and pi. I'm sorry about that. Okay, so now that we have the right problem, let's make a common denominator. And we'll have pi over 2x minus pi over 6 equals negative 3 pi over 6. We'll add pi over 6 to both sides. We'll get pi over 2x equals negative 2 pi over 6. We'll multiply by the reciprocal 2 over pi. These 2's can cancel. These pi's can cancel. X equals 2/3. There's one endpoint. And we'll set pi over 2x minus pi over 6 equal to positive pi over 2. And when we make a common denominator here, we'll have pi over 2x minus pi over 6 equals 3 pi over 6, but this time positive. We'll add pi over 6 to both sides, and we'll have pi over 2x equals 4 pi over 6. We'll multiply by the reciprocal, And we'll get x equals 4, no, pi, those cancel, 4 over 3. So we've got 2 over 3 and 4 over 3. Oh, Mr. Kukla, you almost dropped a sign. Negative 2 pi over 3 and 4 pi, and negative 2/3 and 4/3. So here's negative 2/3. Here's my vertical asymptote. Here's 4/3. Here's my vertical asymptote. And now I need halfway in between. I need 1/3 as the location of my 0 point. And we still know that this is y equals 5. So my graph bends to the asymptotes and passes through the point 1/3, 5. Okay, that's the problem done properly. Let's move on. Cotangent. I'd like to do cotangent. In fact, let's do a negative cotangent. Negative cotangent 3x minus pi over 2 minus 4. Remember again, we set the argument equal to 0 and pi for cotangent, not tangent. Tangent is negative pi over 2 and pi over 2. So I'm going to set this argument equal to 0. I'm going to set this argument equal to pi. I'm going to have 3x equals pi over 2 and x equals pi over 6. I'm going to have 3x equals 2 pi over 2 plus 1 pi over 2 is 3 pi over 2. And when I divide by 3, these 3's cancel, and I'll have x equals pi over 2, which is also 3 pi over 6. Okay, so I've got pi over 6 and 3 pi over 6. Halfway in between is 2 pi over 6. This is y equals negative 4. Draw in the vertical asymptotes. And remember, cotangent normally would look like this, but because I have this negative out in front, I know I need to draw the reflection of that graph. So my graph goes like this. This is the ordered pair 2 pi over 6, negative 4, and we're done with our cosecant graph. Okay, so let's try some going backwards problems, where we'll start with a graph, and we'll do that process like we did with sine and cosine going backwards. We'll identify which trig family, and then we'll find our D, which is the average of the high and low y values. And then we'll find A. A will be D minus the low y value, or high y value minus D. B, in the case of secant and cosecant, is 2 pi over the period. But we know for tangent and cotangent, B will be pi over the period, because the normal period for tangent and cotangent is pi. And then 5 will read C off the graph. We're going to handle this differently depending on what we're looking at. If we're looking at tangent and cotangent, I need to do that a little differently. So let's say for secant and cosecant, I'm reading the furthest left x value, our starting x value. For one of these functions, this starting value is going to be a vertical asymptote, and for the other one, it's going to be the location, the x-coordinate of a high point or a low point. I'm going to do this as well with cotangent. But for tangent x, the c is the x value of the inflection point. Okay, and I'll stress these as we go through them. All right, let's take a look. That's what we're doing. Here's our first graph. It has a point here at 5, 6, 3. It has a point here at 11 sixths, 5 thirds. It has a vertical asymptote at 1/3, 4 thirds, and 7 thirds. So there's my picture. It may be helpful to draw in a midline and sketch in an appropriate curve. But I've seen a lot of students have difficulty with that. And so I might instead say, remember, we said that if you see two complete half periods, that's going to be a secant graph. Secant graph when you see two complete half periods. So I know I'm looking at a secant graph, and I think about my d value as the average of the high and low y values. 3 plus 5 thirds divided by 2. I make a common denominator. I get 9 thirds plus 5 thirds divided by 2. That's going to be 14 thirds divided by 2, which is 7 thirds. So there's my d value. My a value is my d minus my low y, which gives me 2 thirds. My b value is pi over the period. And the period goes from my ending x to my starting x. So that's 7 thirds minus 1 third, which is pi over 6 thirds, or pi over 2 for my b value. And what's c? This is my c value here. So this equation then would be y equals 2 thirds secant, parentheses, pi over 2. Remember, when we go backwards, we use the extra parentheses. X minus our c value, close 2 parentheses, plus our d value. Okay? There's our equation. Y equals 2 thirds secant pi over 2 parentheses x minus 1 third close 2 parentheses plus 7 thirds. And remember, you could always check this on your graphing calculator. I would set my x min to 1 third and my x max to 7 thirds, and my y min needs to be a number below this and a number for y max above that. And don't forget, you need to be set in radians for graphing these trig functions. Okay, let's take a look at this one. So here's my graph, and one of the things I notice first is I have a half period and 2 quarter periods. So I'm thinking that this is secant. I'm having this dreadful thought that the last problem I said was secant, when really it was cosecant. I'm glad I told you all to graph it. Oh my goodness. This is why you shouldn't make videos at 6:30 in the morning. All right, so let's just review that. When I have sine, I will get 2 half periods. Sine's reciprocal is cosecant. Cosecant has 2 half periods. And if I'm graphing cosine first, I'm going to have a half period and 2 quarter periods. And so that will be secant. Now, please notice this secant graph, though, how this goes up and this goes up and the middle one goes down, because that's what cosine is doing. That's not what ours is doing. Ours looks like negative cosine. So this is a negative secant graph we're writing the equation for. Negative secant x. Okay, let's put some values on here. I've got negative pi over 2, 6. I've got 3 pi over 2, 14. And 7 pi over 2, 6. We know our d value is the average of the high and low y values. 14 plus 6 divided by 2 is 10. We know our a value is this high y value minus d, 14 minus 10, or 4. We know our b value is 2 pi over the period, and the period goes from negative pi over 2 to 7 pi over 2. 7 pi over 2 minus a negative pi over 2. That's going to be 2 pi over 8 pi over 2, which is 2 pi over 4 pi, which is 1/2. Our b value is 1/2. And I'm going to read the c value off the graph as our starting x. That's negative pi over 2. So my equation for this secant graph is y equals 4, negative 4, because it's a negative secant, parentheses 1/2, parentheses x minus a minus pi over 2, close parentheses, plus 10. Yes, you're more than welcome to rewrite this as plus pi over 2, and that might make more sense to you to say, oh look, I'm shifting left pi over 2, which is why this is starting at negative pi over 2. Okay. Let's do 2 more secant and cosecant, and then we'll do 4 tangent and cotangent, and we'll be all set. So how about this graph? I've got 1/3, 4/3, and 7/3. Okay, and this point is located at 5, 6, 8, and this point is located at 11, 6, 2. Okay, so what kind of graph is this? Well, it's got 2 complete half periods, so we know that's cosecant. And remember, our choices for cosecant are positive cosecant based on positive sign, and if we had a negative sign graph, our cosecant would look like this, going down first and then up. Ours goes up and then down, so we have a regular cosecant graph to deal with. Okay, so d value is going to be the average of those high and low y values, which is 5. And our a value is going to be our high y minus d, or 3. Our b value is 2 pi over the period, and the period goes from 1/3 to 7/3, so 7/3 minus 1/3, 2 pi over 6/3, which is 2 pi over 2, or pi. Our b value is pi. And here's my starting x value, so c equals 1/3. Okay, so my equation then is y equals 3 cosecant parentheses pi parentheses x minus 1/3 close two parentheses plus 5. You're welcome to distribute the pi through if you feel better about it. 3 cosecant pi x minus pi over 3 plus 5. But I don't need you to. It would make it a little easier to graph on your calculator, and it's certainly a little tidier looking, but you know, some people still make distributing mistakes, and I'd hate you to get the problem wrong because you forgot to just say distribute the pi all the way through. So it's fine with me if you leave the problem like this, and we're all set with this graph. Okay. Next, how about this one? I've got here, I've got here, and I've got here. Okay, so this point is pi over 6 comma 3, and this point over here is 5 pi over 6, 3, and this point down here is 3 pi over 6, negative 11. So, is this secant or cosecant? Is it positive or negative? Well, it has 2 quarter periods, so we know we're looking at secant. And because cosine starts this way, when secant goes up first, we know we're looking at regular cosine, so we're looking at regular secant, not negative secant. This is secant x. Okay, our d value is going to be the average of 3 and negative 11. That's going to be negative 8 over 2, or negative 4. Our a value is 3 minus that negative 4, or 7. Our b value is 2 pi over the period, and the period goes from the starting x value to the ending x value. 5 pi over 6 minus 1 pi over 6, so 2 pi over 4 pi over 6, which is 2 pi divided by 4 pi over 6, or 2 pi times 6 over 4 pi. So the pi's cancel. I can take a 2 out of here with this, and another 2 out of here with this, and I get a b value of 3. Here's my c value over here, pi over 6, and so I'm ready to write the equation. Y equals 7 secant parentheses 3 parentheses x minus pi over 6 close 2 parentheses minus 4. Occasionally you'll see this written with the d value in front of the a value, like negative 4 plus 7 secant 3 x minus pi over 6. But that's the same equation. Okay, so that's going backwards with secant and cosecant. Let's go backwards now with tangent and cotangent. So, I have an interesting challenge with tangent and cotangent. With tangent and cotangent, since the graphs can look the same, except one's negative of the other. So, for example, if I see this, I think, ooh, that's tangent x. But it could also be negative cotangent x. And if I see this, I could say, ooh, that's cotangent x. Or I could say that's negative tangent x. So you need to decide which one it is. I don't care which you decide it as, and I'll give you a technique for figuring out the c value regardless. But you need to decide. Okay, let's start with our first one. passing through 1/3, 7/3, 4/3, and 5. Okay, so we have no a value to worry about. We know that this number is always our d value. A value, we don't care. So what about b? Well, b, remember, since we're talking about tangent and cotangent, isn't 2 pi over the period, it's pi over the period. So 7/3 minus 1/3, pi over 6/3, or pi over 2 is our b value. And so the only thing I need to find now is our c value. Well, it depends. Am I doing a negative tangent, in which case this is my c value, or am I doing a positive cotangent, in which case this is my c value? You have to decide. So I'll write both. Y equals negative cotangent pi over 2 x minus 4/3, close 2 parentheses, plus 5, or, sorry, 1/3 is where we start for cotangent, or y equals, oh my gosh, let's try again because that wasn't negative cotangent. Y equals cotangent pi over 2 x minus cotangent starts here, 1/3, close 2 parentheses, plus 5. Or y equals negative tangent pi over 2 x minus, we start here, 4/3, plus 5. The reason for the difference is because on the cotangent graph, there's a 0 point here at the vertical asymptote. But on the tangent graph, that's not a 0 point. That's a vertical asymptote at negative pi over 2. The 0 point on the tangent graph is the inflection point, which is why we want this x value if we're doing negative tangent. So if we're doing cotangent, we're using this. If we're using tangent, we're using this to find our c value. Let's do some more of those. Okay. How about 0 pi over 3 pi over 6 negative 4. Again, you're going to have to decide if you see a cotangent graph or a negative tangent graph. I'll write the equations for each. We have no a value to worry about. Our d value is this number. Our b value is pi over the period. And our c value depends on what we see. Is this a cotangent graph or is this a negative tangent graph? If it's a negative tangent graph, we use this x value. So y equals negative tangent 3x minus pi over 6 minus 4. But if we're writing this as a cotangent graph, then that's my c value, and I have no shift. Y equals cotangent 3x minus 0, if you like, minus 4. Or you could just write y equals cotangent 3x minus 4, and that would be fine as well. Okay, let's do 2 more. How about this one? Negative 3 pi over 2 pi over 2. Negative pi over 2, 10. So, there's my d value. And there's no a value to worry about. B is pi over 2 minus a minus 3 pi over 2. That's going to be 4 pi over 2. Pi over 4 pi over 2. So these cancel and become 2. These cancel, leaving me a 1 on top and a 2 on the bottom. Be careful with this one. B should be 1/2. And my C value, again, it depends on whether I see this as a tangent or a cotangent graph. Looks like positive tangent graph to me, in which case this is my C value, negative pi over 2. And so we would write y equals positive tangent 1/2 x minus a minus pi over 2, close 2 parentheses, plus 10. But if we saw this as a cotangent graph, a negative cotangent graph, this would be our C value. And we would write y equals negative cotangent 1/2 x minus a minus 3 pi over 2 plus 10. You can certainly tidy these up and write y equals negative cotangent 1/2 x plus 3 pi over 2 plus 10, and y equals tangent 1/2 x plus pi over 2 plus 10. And there you have it. Tangent and cotangent, you decide. I guess we can do one more. They seem pretty straightforward. This is negative 1/6, this is 5/6, and over here we have 2/6, comma 7/3. So my D value is 7/3. My B value is pi over 5/6 minus a negative 1/6. Well, when I do minus a minus, that's plus. 5/6 plus 1/6 is 6/6 or 1. And so I get pi over 1 or pi for my B value. And again, my C value depends. Am I graphing this as positive tangent, in which case this is my C value, or am I graphing this as negative cotangent, in which case this is my C value? So y equals tangent pi x minus 2/6. Don't forget the double parentheses, 7/3. And for the negative cotangent, y equals negative cotangent pi x minus a minus 1/6 plus 7/3. Okay, that's going backwards with tangent, secant, cosecant, and cotangent. I hope this was helpful. Feel free to watch the video more than once, and do ask questions if you have them. Okay, take care, everyone.